In this video, we will demonstrate the equivalence of three definitions of the ellipse. One, a constant sum of the distances from two foci. Second, using the directrix. And third, as a squashed circle. So we will start with a definition of all the points on the plane for which the sum of the distances, or we will call them radii, from two foci is constant. This constant we will define as 2 times a. If you apply this definition to the farthest point on the ellipse, you will find that this a is actually the length from the center to this farthest point, which is the semi-major axis of the ellipse. We define the eccentricity such that the distance between the focus and the center is exactly a times e. Now, a key point here is to find a relation between r and the projection on the x-axis, which is x. To do this, you can study the difference between the square of the two radii. It's a very short exercise. You can do it yourself, or you can click this link to see the derivation. But you find a very simple relation between r, the eccentricity, and x. And from this relation, we get the other two definitions. The first one is just by taking the eccentricity out of the parentheses. We find that r is just the eccentricity times the distance between the point on the ellipse and a line called the directrix, which is located at a distance a divided by e from the center of the ellipse. So this is the second common definition. On the other hand, if we take this expression and we square it, we get a relation between r squared, e and x, and we can get a second relation just by looking at this triangle. So we can express r squared as y squared plus this thing is x minus ae squared, and open the parentheses. The linear term in x cancels from both sides, and we are left with this intermediate relation. Now we want to relate it to the semi-minor axis, which is the length to the top of the ellipse. Now, what's special about this point is that the distance to the two foci is exactly equal, and hence, by the definition, must equal a, and we are left with this triangle with a right angle, which gives us a relation between b, a, and e. And now we can plug this relation into the equation we got. The left-hand side is simply b squared, so we can divide by b squared, and we get the common equation for the ellipse, which is nothing but a squashed circle. If we simply write it a little bit differently, like this, we can see that x divided by a and y divided by a satisfy the equation for a unit circle. And this tells us that the ellipse is a circle which was scaled in the x-axis by a factor of a and in the y-axis by a factor of b.